In this video, I'm going to show you how to find the area of a circle. Here we've got a circle, and we've got two things labeled. First, there's the radius, r, which is the distance from the center of the circle to the exterior of the circle. And then we've also got the area, a, which is just the amount of space inside of the circle. This formula right here is what we use to compute the area of the circle, and it's in a box because it's really important. You're going to see it all the time throughout math. So it just says that the area equals pi times the radius squared. Pi is just a number, it's just a constant. It's irrational, 3.14159. It goes on forever, and it can't be represented by a fraction or anything, so we just represent it by the symbol pi. But the area is just this number pi times the square of the radius of the circle. Pi always stays the same no matter what the circle is. The radius is the thing that can change for different circles. Small circles will have a small radius, big circles will have a big radius. And to find the area, you just have to plug the radius into this formula and compute. Alright, so let's put this formula to use with an example. What is the area A of the circle with radius r equals 4 centimeters? Here we've got a little diagram of the circle. We've got the radius r equals 4 centimeters, and we want to find the area within the circle. So we're just going to plug this radius, r equals 4, into our area formula here. So we'll write area equals pi times the radius squared. Well, the radius is just 4. So take 4 and square that. So let's simplify that. Area is just equal to, well, 4 squared is just 16, so 16 pi. But wait, we're not done yet. We've done the computation, but we also have to take into consideration the units. So the radius was given in centimeters. That means the area should be in square centimeters, because area is two-dimensional space. So 16 pi centimeters squared. And that is our area. Including the units might seem like a small technicality, but it's actually really important to include that centimeters squared, because if we didn't include it, we wouldn't actually know how big our circle is. 16 pi without any units on it is pretty meaningless in a physical sense. Like, do we mean 16 pi meters squared? That's an even bigger circle. Or 16 pi centimeters squared? That's a small circle. So by putting centimeters squared, we know that we're referring to the small circle, 16 pi centimeters squared, not a big circle of, say, 16 pi meters squared or miles squared. Now 16 pi is our true exact answer, but to turn this into a more familiar decimal, we can approximate the area using an approximation for pi. So we can write that the area is approximately equal to, approximately just indicated by some squiggly lines, area is approximately equal to 16 times our approximation for pi. Pi is roughly 3.14. That's just rounded to the nearest hundredth, centimeters squared. So if we use this approximation, then we can go ahead and multiply it out and get that the area is approximately 16 times 3.14, and that comes out to 50.24 if you punch it in your calculator, centimeters squared. So that's also another way to see the area. Now keep in mind that 16 pi is the exact area, but we can approximate it using this approximation for pi just to make it a little bit more digestible, just to put it in decimal. But if you want the exact answer for the area of the circle, you need to use the 16 pi. 50.24 is just an approximation. It's only really close to the area, but not exactly. Alright, so now that we know how to compute the area of a circle, let's shake things up a bit. So still using the area formula, but this time, what is the radius of a circle with area 49 pi inches squared? So we're given the area, and we want to find the radius. The radius is what we don't know. That's what we need to solve for here. So the way we're going to do this with this area formula is we're going to rearrange it a little bit so we can get the radius r as an expression of A, the area. So our first step, let's isolate the r squared by dividing by pi on both sides. So divide by pi, and that way these pi's will cancel out, and we just get area divided by pi equals r squared. All right, and we just want r by itself, so we want to cancel out that squared, and the way we can cancel out the square is by taking the square root of both sides. So normally we'd be wondering, do we use the positive or negative square root? In usual math problems, we'd just say plus or minus square root. We'd consider both possibilities. But because this is a physical problem, because we're interested in an actual distance, r is just a length, we're just going to take the positive square root. The negative square root doesn't really make sense in this physical context. So this simplifies to the square root of area, A, divided by pi is equal to r. The square root and the square cancel, and we've just got r. Okay, great. So now we've got r as an expression of A, and we can go ahead and plug in our area into that expression, and that'll give us our radius. So let's go ahead and do that. So square root area is 49 pi. So put in 49 pi for A, and then divided by pi, and that is equal to our radius. And now it just remains to actually compute this thing. Let's simplify a bit. So pi up top and pi on the bottom, these pi's cancel, and we've just got r equals square root of 49. And square root of 49, well, that is just 7. So 7 is equal to r, the radius. But wait, we're not done yet. We've got the number, but what about the units? So we need to include the units here. So r equals 7 what? 7 miles? 7 centimeters? No, 7 inches. Our units are in inches. Area was given in inches squared, and that was for square units. Radius is just a distance, so linear units, so just inches. 7 inches. That's our radius. Here's another question which requires us to think a little bit before we use the area formula. So we want to find the area of a semicircle with diameter 10 inches. So this time we're not finding the area of the full circle, we're just finding the area of the semicircle, the half circle here. And we're not given the radius, but we're given the diameter, which is just the distance across the semicircle. So how are we going to do this? Well, a semicircle is just half of a circle, so that means that we can find the area of the semicircle by just finding the area of the full circle and taking half. So let's write that down. We have that the area of the semicircle is equal to a half times the area of the circle. And area of the circle we can just use, we can find that using our area formula. So area of the semicircle is equal to a half times the area of the circle. Area of the circle is just pi r squared. Alright, so now we've got the area of the semicircle in terms of the radius r, but we're not given the radius r, we're given the diameter, which is 10 inches. But the radius is just, that's the distance from the center to the exterior of the circle, and two of those make up the diameter. So the radius is just half of the diameter, and half of 10 inches is 5 inches. So radius is just 5 inches. So we can plug that into our formula here. So equal to a half pi times the radius 5 squared, and we can just go ahead and simplify that. So that's equal to half pi times 5 squared is just 25. So really just 25 over 2 pi. And remember, we need units we have the diameter in inches, so area is going to be inches squared. So that's the area of the semicircle. And remember, if we want just a regular decimal number here, we can approximate this area using the approximation 3.14 for pi. So this area is approximately equal to 25 over 2 times 3.14 inches squared. And if we multiply that all out on our calculator, we get approximately 39.25 inches squared. So there's another approximation for the area, but that is our true exact area. This one's just a little easier to read. Here's a final example, and this one is going to be the trickiest. We want to find the circumference, the distance around a circle with the area is 25 pi centimeters squared. So we know the area, we don't know the radius, and we want to find the circumference. So let's just take inventory of what we know here. Well, we know that the area is pi r squared, and we know from before, previously, we've learned that the circumference is just 2 pi times the radius, r. So what can we do in order to compute the circumference? We don't know the radius, so we can't compute it directly. But we've seen before that if we know the area of a circle, then we can find the radius of the circle. We did that in the second example. So let's go ahead and do the same thing here. We're just going to rearrange this area formula to give us the radius as some expression of the area. And then we can compute the radius and then stick it in this formula to compute the circumference. So yeah, let's go ahead and do that. So remember, our first step was to isolate this r squared. So divide by pi on both sides. That'll isolate the r squared. And we just have area divided by pi equals r squared. And then to get rid of the squared, we can take the square root of both sides. And we're just interested in the positive square root because that's the physical quantity. We're talking about length here. And then the outcome of that is just square root of area divided by pi is equal to the radius. Great. So now let's just stick in that area into this expression. So square root of 25 pi divided by pi is equal to the radius. And cancel out the pi's here. And then we just have square root of 25. Square root of 25 is just 5. So 5 is equal to the radius. And we can stick that into this formula here for the circumference. So circumference is just 2 pi times the radius of 5. And if we multiply that all out, then we get circumference is equal to 10 pi. Great. Now remember, this isn't our final answer yet. We need units in order to specify what this 10 pi actually means as a physical quantity. And area was given in centimeters squared. That means we're working with centimeters. And circumference is just a distance around the circle. It's perimeter, so one-dimensional units. So that means just centimeters. So there we go. That's our circumference. And again, if we wanted to approximate the circumference as just a plain old decimal number to 2 decimal places, then we can just use an approximation for pi. So we can write circumference is approximately equal to 10 times approximation for pi, that's just 3.14, then keep our units. And if we compute that, then circumference is approximately, nice, we don't even need our calculator to compute this one. We just move the decimal place once over to multiply by 10, and we get circumference is approximately 31.4 centimeters. So That's our approximation. But this 10 pi centimeters, that's our true exact answer. The area of the circle is a formula that will come up over and over again throughout math, so be sure to remember it. In the future, we'll also learn how to use the area formula to calculate area of sectors of circles, kind of like the semicircle problem we did earlier, but for any size piece of the circle.